All right. Last session, last 15 minutes. We talked today a lot, and we heard a lot today about, let's say, OEMs and a lot of activities in hydrogen combustion development. But development means also to validate and to calibrate in the right environment. We as AVL, we are a global testbed supplier, and we are, of course, also requested to provide the right answer solutions to have. Oh, sorry, I'm going here. To provide solutions which are appropriate, of course, also for hydrogen engine testing. And we want to share with you today a little bit the insight into what are the relevant aspects to look at. When we have hydrogen, first, of course, a quick look at the properties and the impact to the test cell. Quickly to go through. We have a high diffusion. We have, of course, also in such a test cell, the risk for accumulation of hydrogen if it's not well ventilated. Hydrogen is rising up very quickly. So that means, because it's much lighter, significantly lighter than air. And we have, of course, the danger of explosion. That's the biggest point and the biggest fear everybody has. I have to avoid explosion. But as we know, hydrogen alone cannot explode. We need an ignition source. And we need, of course, also oxidation air. And finally, we have to look into aspects, for example, like embrittlement, so material, which is also, of course, affected by hydrogen. But that's just a little bit as an introduction, let's say, to the hydrogen and the relevant points we see necessary to look at. From a holistic point of view, on the test facility, it's a lot what we have around our test engine. But first, we have to think about, we need to have the hydrogen supply. So the external supply, the hydrogen storage, and the supply to the test rig. In the test cell, of course, we are also expecting a very accurate, a very repeatable hydrogen consumption measurement for these specific engine technologies. And not to forget, we have a lot of instrumentation, and we see an impact of the hydrogen combustion into this instrumentation to look at. And overall, we have to look into the test cell, the test facility, and the safety aspects of such a test facility. Let's go step by step now a little bit through this point. Hydrogen supply and storage. Of course, when knowing the consumption, the average consumption of my workload of the facility, then I can think about what is the right storage. Is it a bottle? Is it a bundle? Is it a trailer? Is it a super trailer? Or is it maybe also liquid tank? But that's an easy calculation. You will see this in the handout, because by just looking to the logistic limits, it's very easy to decide what is the, let's say, the best choice for my test facility operation. So then looking to one example here, if I have, for example, a 300 kilowatt, let's say, permanent workload over, let's say, 80 hours a week, I need to replace, for example, a bundle 227 times. Impossible, of course. So the only one option is to look into a trailer where we have different technologies, but you see also here, this is quite challenging. So very soon we are towards, let's say, liquefied tanks, or we also at, let's say, electrolyzers to be installed at site. These are the options which are typically, of course, done always with local experts, local suppliers, but is the relevant, let's say, starting point. On the next slide, here you see, this is AVL in Graz, our headquarter from our global business. And you see here, this is our hydrogen storage and distribution system. We are in the middle of the city. And this was really, really a big task, which took, let's say, about 1.5 or 2 years with the authority to negotiate the necessary measures, how it is possible to have placed here, really in the middle of our area, such a hydrogen trailers, and from there to distribute, to feed either fuel cells via buffer tanks, or to go, let's say, also to engine testbeds, of course. Yeah. But it's possible. And as you see here with this firewall, also in this concept, we even considered the possible extensions to liquefied hydrogen storage. So these concepts are, let's say, a reality, but important is always to say this takes time especially when working together with authorities. Next point, hydrogen consumption measurement. Consumption measurement looks or sounds in the first look very easy. But what is the expectation, of course, from an engineer on a test bed? The first point is, of course, it's expected to comply with, let's say, combustion injection concepts. And what is behind here? Of course, we need to provide a very stable supply pressure, flow supply to the engine. And this, in concepts, what we are supporting nowadays with port fuel injection or with, let's say, low pressure DI. You see here the pressure levels. It's very difficult. The pressure levels here are rather low. But today, test facilities, when they are modernized, they are thinking about 10 years, 15 years ahead. So they talk about high pressure, let's say direct injection, where we have heard today, that's a dream. But the point is, test facility should be prepared to manage these high pressures. And these high pressures means not 50, 60 bar, it means 200 bar and higher. And that's, of course, a very important thing. Let's say it triggers necessary things on the safety side. Yeah, we expect, as I said before, let's say continuous pressure supply, and this, of course, also offers a good accuracy and a good repeatability of the measurements, which is, let's say, always the boundary condition of every engine development to have excellent repeatability of the test results. And such a system is not just a flow meter. Such a system is an integrated total system, which also provides check functions, automatic routines for purging or initialization. So it's, I wouldn't say plug and play, but it's a very, let's say, industrialized, ready to use subsystem to be installed in such a test facility. We call this Hydron, very nice name, and we have this in different models, as you can see here. Next point, instrumentation. Of course, fuel consumption is also instrumentation, but a very specific one. But we have a lot of instruments, a lot of measuring systems on the test bed, which needs to be carefully checked. The simplest one is, of course, the air side. We know we have a higher, let's say, airflow ratio. We have, of course, let's say, also we run with higher lambda. So that means the air mass flow to the engine is significantly higher. This needs to be checked with the existing equipment, straightforward. But when we have hydrogen, when we are burning hydrogen, we have also a lot of, I would say, challenges on the emission side, where we also heard today, it is mainly NOx. On the emission side, it's mainly, let's say, a little bit on the particulate number, but the instruments have to deal with that. And they have to deal, let's say, with a significant amount of water. On this diagram, you can see here, based on the humidity of the combustion air with about 15 grams per kg, you can see that we are, compared to a diesel engine in the black color, we are doubling, let's say, the hydrogen, the water content in the exhaust. And this, of course, has an impact to the instrumentation. What it means for gaseous emissions, but also for particulate instrumentation. So gaseous emissions, we have a cooler, we have cross sensitivities, we have, let's say, quenching effects, and we have also, of course, our multi-component measurement, FDR, where we have to look to the evaluation software. The instruments need to be prepared for that. We are proud to have here already, let's say, developments in which we are providing to the industry already starting from this year. Another point is that with these devices, what can happen? I mean, I know we have combustion anomalies. That means we have misfiring. We have a lot of this stuff, means the instruments will be exposed to hydrogen. So we have to make a risk assessment if these instruments can still be used without a problem. And I think this is very important for every owner of a facility to think about this point. Yeah, so it means countermeasures in the safety, overall safety chain, safety functions need to be considered. Yeah, and as I said already now, this needs to be integrated in the overall safety concept, by means of how to detect, let's say, misfiring and how to react on that, but how to control then or shut off emission measuring devices and things like that. I have to come closer. And we have a hydrogen slip, which is a new component, which needs to be measured, and which is, of course, here best possible to be combined from an instrumentation point of view with an FTR as an additional device. Combustion analysis, I think a lot has been discussed already and spoken. Here, just to mention that, of course, AVL is known as a company, let's say, which had a strong focus, of course, on combustion engines from the very beginning. So that means combustion analysis technology was and is our daily business. And what we can say is our indicating systems are also ready for that. So we can also provide you here whatever you have, maybe from AVL, we can also provide the updates necessary for the hydrogen application. Right. Yeah, not mentioned today, but maybe in 2 words, blow-by could become critical because, as we have heard, I think there was one statement talking about optimizing, let's say, the cylinder liner, let's say, displacement by looking at friction, and then, of course, minimizing here maybe the blow-by, but it's also the question how to manage, let's say, the hydrogen in the blow-by. And this could be, let's say, of a very, I would say, dominant portion, which is then, of course, a risk for the engine to explode, but also a risk for the instrumentation to create problems, because the instrumentation is basically not explosion proof. So that means protection measures, some mitigation measures are necessary, either on the engine itself, like concepts that are currently discussed on crankcase dilution, active dilution, or in bigger engines, we have this, let's say, pressure relief valve, which of course is the mitigation measure when being tested on the test bed and in final use. And we have a hydrogen sensor we can install in the line. And in our case, we are coming up soon with also even hydrogen proof, explosion proof blow-by version for such customers who are not sure what is the status of their maturity level of their, let's say, crankcase ventilation system. Yeah, to be quick, all that together, of course, needs to be combined with the necessary measures on the let's say, facility system and the facility safety concept. Explosion, I mean, what I did not say is what is mainly triggering the danger of hydrogen in the test cell is the pressure. The higher the pressure release, the possible release into the test cell, the higher the demand, of course, also to dilute it with a suitable cell ventilation. And all this has to become part of the overall, let's say, safety concept, which needs to be engineered and which needs to be aligned with local regulators and local authorities to get at the end the final check to say, fine, we can go with that. Yeah, I will jump over. I will already explaining this, what's behind. Yeah, just to say, whatever the safety assessment is concerned, we can also here accompany the customer and go up to a certain stage and to define what are the necessary, let's say, mitigation measures for the whole facility from the whole holistic point of view. Summary, I think good in time. When having a test cell, a nice diesel test cell with a lot of equipment, I think we all know that this is just the view of the AVL, let's say, portfolio. So we are covering, of course, in our long activity everything. First of all, when we go to a hydrogen, let's say, engine on the test bed, we have to look to the hydrogen supply and the suitable hydrogen consumption measurement. In our case, it's called hydron. We have to look to the air side, to the, let's say, the combustion air supply with the right, let's say, sizing performance. There's I think it's just a typing error, I'm sorry about. Then we have to look carefully on the emissions equipment, what is, let's say, in place, what is in use to manage this significantly higher water content and to avoid also here, let's say, measurement errors. blow-by, we already mentioned, is also a point which need to be carefully looked at. Then, okay, simple stuff like simple pressure transducers around the engine, but also specifically the combustion analysis items, cell ventilation, and the overall cell, let's say, test cell safety concept. What do we see here? It's a big portion of the test cell which needs to be looked at. Very often I get the answer, it's just a sensor to be put somewhere in the ceiling. That's the opposite of the answer. With that, thank you very much for your attention.
So we've got time for 1 or 2 questions.
Thank you very much for the presentation. I was just wondering, because you explained that we need to reduce by 30% the emission of CO2 by 2030. Do you think that it will be possible to have such a refueling network, for instance, in Europe, of refueling station of hydrogen every 100 kilometers or thing like this?
I have to hand over. This is your part. Take the microphone.
Yeah, if it will be possible to have such the network and the infrastructure, on the highway and so on.
Use your microphone.
Yeah.
Now, I think, as we have, I think one of the colleagues already mentioned, we have a European target which says we need every X kilometer, we need a hydrogen refilling station. They also define whether it's for truck or passenger car. As I think we can share this also later, it's really explicit targets. The same for the battery charger, also whether it's high power, low power, and how many charging points. Then, I mean, the question will be, do we really need both, or will be battery that dynamic and dominant that the focus will be on battery? But the targets are here, and I mean, it will be interesting how we really, also who will take care that these targets will be really realized, no? Because battery electric, for example, you have, I think, Daimler, Scania, and Volvo, and they by themselves take responsibility for installing 1,700 battery charger because they see that we are too slow, no? But if no one does this for hydrogen, then we have a problem, no? But therefore, the targets are here, but we need to monitor really continuously whether or not this can be realized. Hope that helps.
Yeah.
Okay. One more question?
Yeah. Thank you very good. Thank you very much for the good presentation. It's about the energy consumption during the compression of the hydrogen and the transportation. What is the percentage of that one and the overall production of hydrogen as a fuel?
Maybe I'm not the right person to
Yeah, you are
answer
not
this,
the right
yeah?
person. Maybe you cover it partially.
Maybe the audience can jump in.
Yeah, because they are talking about the compression, cryogenic, and all of that one consume energy.
Yeah.
Maybe
And
I'll find it. There is a presentation tomorrow about windmill machines and compressors for hydrogen. Exactly that.
okay.
So perhaps we can talk about that.
Well, okay. Thank you very much. Thanks.
Okay, so with that, I think we need to bring today to a close as far as the sessions are concerned. So we'll just
Thank you.